Welcome to another video from explainingcomputers.com. For a while now, some of you have been asking me to make a video about a tiny little computer called the Raspberry Pi. And so, this time I'm going to do just that. The Raspberry Pi is a low-cost computer which was created to help people learn programming, but which can be used for all kinds of things. As you can see, it's about the same size as 12 real raspberries, but unlike the array of fruit, features a system-on-a-chip 700 MHz ARM processor. It also comes in two versions, called the Model A and Model B, which sell for $25 and $35 respectively. Here I've purchased a Model B, which has 512 MB of RAM, two USB ports and an Ethernet network port, a micro USB power connector, an HDMI socket for connection to a TV or computer monitor, as well as RCA video and audio jacks as an alternative means of AV connection. On the underside, there's also a standard SD card slot, and on the top, a set of GPIO or General Purpose Input-Output pins, which can be programmed to control all kinds of things. To make a Raspberry Pi work, you'll need an SD card to store its operating system, programs and data, and here I'm using a 16GB SanDisk Extreme, although any card from 4GB upwards will work. You'll also need a 5V USB power supply that can deliver at least 700 mA, and to be safe, here I'm using a 1500 mA adapter available from the Pi Hut. While a Raspberry Pi can run naked, to prevent damage it's sensible to give it a case. The cheapest option is to download this PDF from the raspberrypi.org archives and then to print it out, before carefully cutting it out with a pair of scissors. The paper outline then needs to be traced onto a piece of cardboard. Finally, you need to once again get busy with your scissors and also some sticky stuff in order to finish off your very own, totally DIY Raspberry Pi Punnet. Alternatively, if, like my mate Dan, you have access to a 3D printer, you can download a Raspberry Pi case from Thingiverse and print it out. Although, as you can see, making two parts that fit together properly can be somewhat of a challenge. I therefore initially decided to buy this injection moulded blue plastic case, which housed my Pi very well indeed. This said, having ordered this very sensible covering, I discovered an amazing alternative from Camac. This low-cost kit consists of two clear plastic pieces and quite a few washers, nuts and bolts. Assembly is not trivial, though, as I hope you'll agree, the final result is somewhat splendid. Granted, the circuit board is not protected on the sides, though this can only improve the cooling. More significantly, your Raspberry Pi ends up looking like something out of a science fiction show, and in particular like Aurak from a 1970s BBC TV series Blake 7. Before you can use your Pi, you'll need to download some software and put it on the SD card. Here I'm downloading Noobs, or New Out-of-the-Box Software, from raspberrypi.org. This is currently a 1.1GB download and hence takes a little time. Once it's complete, it's also advisable to download the formatting tool provided by the SD Card Association, and which should ensure that the SD card you're setting up has the best chance of working properly with your Raspberry Pi. Once this smaller download is complete, you'll just need to install the formatter and then to run it in the normal way. Note that here you cannot see my whole screen in this capture, so I'm having to move the icon into view so that you can see me activate it. Once the formatter is running, you need to ensure that you're going to format the right drive, and also to make sure that in Options you set Format Size Adjustment to On. With the format complete, you can then finally extract all the files in your Noobs download zip file to the SD card. Alternatively, you could extract the files somewhere else first and then copy them across to the SD card. Regardless of how you choose to do things, it will take a little time, but when you're finished, you'll end up with an appropriately set up SD card ready to plug in to your expectant Raspberry Pi. With my Pi cased and fitted with its SD card, I've connected it to my Plasma TV and also plugged in the USB power supply, as well as a keyboard, mouse and an Ethernet lead to my internet router. I then just need to turn things on, and as you can see, I've put a power meter in the circuit so I can monitor how little energy my Raspberry Pi actually uses. OK, the Pi is finally booting up, but I'm afraid the screenshots here won't be brilliant as I'm recording with a camera off a TV screen rather than performing screen capture. Anyway, things seem to be happening, Noobs is initializing, and we finally arrive at the Noobs menu from which we can select an operating system to install. Here I'm going to go for the top option, which is a version of Linux called Raspbian, and once I've confirmed my choice, the setup will begin. Clearly, this will take some time, but while my Pi is flat out sorting it all out, we can take a look at the power meter to see that it's only drawing a little under 3 watts. This is quite impressive and nearly 100 times less than the Plasma TV to which it's connected. Oh well. Speeding ahead in time, the installation is finally completing, and I just need to press OK to reboot into our new operating system. It's cool to see some lowish level code on the screen, though again I'll speed through things until we reach the configuration utility. Here I'll leave things alone and just select Finish, and once again reboot the system. This will take us back eventually to some more colourful Raspberry graphics and scrolling code, followed by a black screen with the LED from my mouse reflected in it, and finally we get our first look at the Raspbian desktop. So what am I actually going to do with my Raspberry Pi? Well, before I program it to control a robot army, I'll settle for proving that it can function as a low-power Office PC. So, I'm going to visit the Pi store, and when this loads up, we can see that it's got lots and lots of apps available. But however nice these are, what I really want is LibreOffice, so we're going to search for that. And here it is, all waiting to be downloaded for free. So, I'll select the LibreOffice download, and now it wants me to be registered for a Pi Store account. And of course I'm not going to share the account details I'm going to create, so I'll time shift forward once again. Right, quite a few minutes later, here we are coming to the end of a LibreOffice installation. So I'll just press a key to continue, and it's always difficult to decide which one, and so now I can close down the Pi Store, and in the menu we have access to LibreOffice. Here I'll select the Writer word processor, and in a few seconds or so, in fact quite a lot of seconds or so, we'll find ourselves running a slightly slow, if perfectly serviceable, Office package. Hurrah! OK, for a final test, we'll get rid of that and try and view the World Wide Web. To do this, I'll select Internet and then the Midori web browser. And when it eventually comes up, I'll type in a familiar web address and hopefully it'll work. And it actually does. And so, with a word processor and a web browser working properly, that seems like a good place to leave things for today. The Raspberry Pi was created as an educational tool, but has already been embraced for many other purposes, including media player, low-power Office PC, and robot controller. More information can be found at raspberrypi.org. But now that's it for another video, and I hope to talk to you again very soon.